It's Mr. Toops, the Jedi of Believe, and you're here in the office of the Always Believe House. Oh, we're about to have FUN, fun, because algebra is a study of functions. And what does function start with? FUN. Oh, fun using numbers. We are going to go over your unit test, your next unit test today. It's over writing equations. It's about getting the table and the correlation coefficient from a table and the linear transformations. So a magical whiteboard appears. Let's start rocking and rolling. So we're doing number one real quick. I'm going to zoom in. Okay. Remember, on a problem like this, you usually want to identify the y-intercept first. So right here, my y-intercept's 4. That's the distance in miles I'm starting, and my distance keeps going up, doesn't it? So the y-intercept's 4. That's the initial amount of miles. And what's the rate of change? I'm going to go from here to here, aren't I? So I'm going up and over. I'm going 4 to 10. I'm going up 6. And then I'm going to the right 0 to 10. 0 to 10. So I'm going up 6 and over 10. Remember, the top number's up or down, the bottom number's to the right. That's going to simplify to 3/5. So the rate of change is 3/5 miles, which is y, per minute, which is x. Remember, this is y per x. The equation would be 3 over 5x, that's my m, and my y-intercept is plus 4 in it. So if I were to graph 3 over 5x plus 4, I would get that line. And if I hit Control T, I would get those ordered pairs on that T-chart. F-U-N, fun. Let's keep going. Okay. On this one right here, I want to write a line that passes through the point 3, -4, that's by x and y, and is parallel to this line. This is the slope. So that's my m. If it's parallel, it won't change, will it? Okay, so really quickly, I'm going to put m equals 1 over 3. My x is equal to 3, and my y is equal to -4 in it. I'm going to write the equation of a line, which is y equal mx plus b, and I'm going to plug all these in. The only thing I don't know is b. So I'm going to replace the y with -4 equals my x, or my slope is 1/3, times my x is 3, plus b. I'm going to put this into InSolve and solve it for b. All you do is type that into InSolve, solve it for b. I'm going to do this in my brain. 1/3 times 3 is 1. You move it over, you're going to get b equals -5. So if you were to type that into InSolve, you would get -5. So the equation, I'm going to need the slope, and I'm going to need the y-intercept. Y equals 1 over 3x minus 5 is going to be the equation. Piece of cake. So we got to get the slope. We're going to use our point as x and y. You plug it into the equation. You solve for b. Either use InSolve or solve it manually like I did. Get your b and write your new equations. Piece of cake. I'm going to show you how to do 3 with the calculator, okay? First off, let's do this by hand. Okay, so right here, I'm going to get the ordered pairs from here. Remember, this is y minus y1 equals m parentheses x minus x1. First off, let's get the slope of this line. We're going to put a dot here and my next dot here, down 3 over 1. The slope is -3. This one's wrong, this one's wrong, and this one's wrong. Notice there's only one -3 slope. So this one right here is the answer. Now then, look at this point. This is my x and my y, but remember they're opposites, right? Okay, so the opposite of +1 is a -1. The opposite of a -1 is 1. And look right here, that point is -1, 1. So this one would work. Now then, on your calculator to do this, you're going to physically graph that line. So you're going to go to your calculator, y minus 1, and we're going to graph. We're going to go to b. And to graph that line, it's not solve for y. You're going to type in the word InSolve. You've got to be able to do this. This is a huge concept you're learning. So you type in InSolve, you start a parentheses, and I got to get my equation out because I did not print this out. So it's y minus 1 equals negative 3x plus 1. So y minus 1 equals negative 3 parentheses x plus 1 close parentheses comma y. I want to solve it for y, don't I? So notice, if I graph this, it should go straight to what that graph looks like. I'm going to hit enter, and notice that's exactly what the graph looks like, doesn't it? Piece of cake, okay? My y-intercept's the same. It goes through negative 1, 1. It all works out, okay? That graph would match up to what's on the equation of the line. So the answer to this one is A. Make sure you can graph typing in the word insult. Number 4, okay, we're going to get the correlation coefficient of this. What this means is this does not exactly graph a line. It's a scatter plot. And your correlation coefficient goes from negative 1 to 0 to positive 1. This is a negative correlation. This is a positive correlation. A negative correlation would go down. A positive correlation would go up. This is a strong negative. This is a strong positive. And as you approach 0, the correlation gets weak, okay? So the closer we get to 1 or negative 1, the stronger the correlation is. Usually on your STAR test, the correlation coefficient is going to be over 0.8, which is strong, okay? Anything really over 0.6 is a strong correlation. Now then, let's put this into the table. So 1570, so I did not print this out, so I don't have it. So home, we're going to make a spreadsheet, 1. We're going to add a spreadsheet, 4. We need x and y at the top. And now that I need to type in my x's, I forgot to print this out, so I need to 0, 1, 5, 7, 10. 0, enter, 1, enter, 5, enter, 7, enter, 10, enter. I'm going to go up back to the 0. Okay. If I could get this from stopping. Okay. So I'm right here. Now I need to put in my y's. So I'm going to go to my paper again. My y's are 1,000, 930, 700. 1,000, 930, 700. And then I'm going to get my last two. 1,900, 930, 440, and 110. 440 and 110. So 440 and 110. So I have this on here. Now then, we're going to do the linear regression, menu 413, and we want to find out what the R is. So we're going to do menu, statistics, stat calculation, linear regression, menu 413, X down, Y down, and then hit enter. And notice right here, that R is the linear regression. Notice the money's going down, so my linear regression is negative. And it's negative 9.861. That is almost negative 1. That is a very strong negative correlation. That means the dots trend down and they're very close to the line, okay? So I'm going to go to my paper. It's negative 9.8, what was it, 0.9863? 0.9861. Okay, and this is a very strong negative correlation. Okay, so this is a strong negative correlation. And remember, it's negative 0.9861. So this is a scatter plot that trends downward. The dots are very close to the line. Let's go to the next one. This one right here, I like using growing number and starting number. The growing number is going to be your slope, and the starting number is going to be your rate. So read the problem. They charge, okay, Bubba Bob works for a paddleboard company at Lake Tejas. That's in East Texas, Spring-Fed Lake. Very cool to go to. They charge $20 fee to rent the paddleboard, then $5 each hour. This would be your starting number. This would be your growing number. So it's going to be 5x plus 20. The price is going up, so my growing number is positive. So 5x plus 20 would be the linear function that generates the cost, okay? Piece of cake. Just remember, growing number, starting number. Try to find your starting number first. Your growing number is going to be the rate, okay? Turn the page, number 6. Okay, write the equation line that goes through this point and is parallel to this. Our slope is going to be 3/4. So one more time, our m is 3/4. Our x is going to be what? -5. And our y is -8. We need to put this in y equal mx plus b, and we're going to solve it. We know all the letters but b. So y is -8. Our m is 3/4. Our x is -5. And our b is going to be here. The b is going to end up being a fraction. So I'm actually going to put this in the end solve because this is not going to be a nice number, okay? And let me make sure I did that right. I did that right, okay? So I'm going to go to my calculator. I'm going to hit home. I want to calculate A, and I'm going to do end solve. So menu, algebra is 3, numerical solve is 1. And we are going to solve this equation. I need to type it in. -8 equals 3/4 times -5. So -8 equals, control divide, 3 down 4. Hit the right arrow button. And then times, I need to multiply that by, what is it? -5 plus b. Let me get to the calculator. -5 plus b. And then I need to solve this for b, comma b. This is going to be a fraction, okay? Comma b. So I've typed it in, -8 equals 3/4 times -5 plus b, comma b, hit enter. And my y-intercept, or my b, is going to be -4.25. And now then I'm going to hit enter. And then I'm going to do menu to enter, and that should turn it into -17/4. So it could be -4.25, it could be -17/4. Menu to enter will flip it from a decimal to a fraction, okay? So we're going to go to our paper. Our b is equal to -4.25, or -17/4. So the equation is going to be y equals 3/4x minus 4.25. Okay, that's going to be the equation of the line. So you're going to solve it for b. You're going to reuse the slope and use that b to make your equation. This is our slope. This is our y-intercept. Piece of cake, okay? Number 7, we got to do another linear regression. We're going to type this in. We want the function rule. So we want the m equal and the b equal, and we're going to make the function y equal mx plus b. So we're going to type this into a spreadsheet. So go to your calculator. We're going to hit home. We're going to click 1. We do not want to save anything. We're going to add a spreadsheet 4 and then put the x and y at the top and then type in the spreadsheet. So I'm going to go back and I'm going to get 136,812, 136,812, 136,812, 136,812, 136,812. I got those in. Now then I'm going to go up, and now I'm going to punch in my y's. So my y's are 510, 430, 310. And one more time, 510, 430. Just do 510 and 430. 510, 430. Now I'm going to try to get the last 3. And then I need 310, 230, 70. 310, 230, 70. 310, 230. And 70. Notice on this, the x's are getting bigger, the y's are getting smaller. This is going to be a negative slope in it. And it may not be a perfect one if the r's not 1. So we're going to do a linear regression. Menu 4, 1, 3. X down, y down, and then enter. And right here, notice our r is -1, so it's a perfect line, but this is the m and b we want. So our m is -40 and our y-intercept's 550. So -40 and 550, -40 and 550. The equation would be y equals -40x plus 550. Ho, 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 ho. F-U-N, fun, fun, fun. Go to number 8. Write this line in slope-intercept form. I'm going to zoom in. First off, you want to do is identify the y-intercept. It's -1, right? That's equal to the b. Now we're going to get the slope. We got to go up and over. That's my next grid point. We are going up 1 over 2, so our slope is 1 over 2. So our equation is going to be 1 over 2x, and then what is it? Minus 1. Piece of cake. This is the M, this is the B. All you got to do is tag the y-intercept, get the slope, and bam, you got it. Piece of cake. You can't miss this. Number 9. If it's a causation, X makes Y happen. Just remember that. Remember, X is your input. If you input something and it makes the output happen, it's a causation. For instance, I input the number of hours, my output is the pay I get. The number of hours impacts the pay I get. One that is not a causation, let's take your shoe size. If you input your shoe size, that will not output your IQ, is it? Your shoe size is not a causation of your IQ. Now then, let's go to here. The number of people at the fair and the revenue generated from the vendors, the more people that are at the fair, the more they're going to spend. It is a causation. X is making Y happen. Okay? The miles driven in a car and the amount of fuel left. If the more miles you drive, the less fuel. X is making Y happen. That's a causation. The shoe size of a student and their grade. Your shoe size does not impact your grade. That is not a causation. The number of hours worked at your job and your paycheck. The more hours you work, if you're getting paid by the hour, the more you get paid. That is a causation. Piece of cake. Now then go to here. This is, you just learned this, so try to get this down. Your f of x is your original. This is our f of x here every time, okay? That's the original line. And we're either going to move it up or down or change the slope. Okay, so I'm going to put f of x, and then I'm going to put a number here and a number here. This changes the slope, and this moves it up or down. Okay, the bigger the number gets, the steeper the slope, the smaller it gets, the flatter. If the slope is 0, it's flat, okay? And a negative would flip it. So let's look at this. The 1/2 x. This is going to make this line flatter. Okay, so what's going to happen is that blue line is going to decrease in slope. Which one matches up to that? It's this one right here. Do y'all see how this line is getting flatter? You're flattening the line out. The next one, this plus 2 is going to move the line up 2. Do y'all see how this was moved up 2? This one goes to here, okay? Just move it up 2. This one right here is going to make it steeper. Okay, the 3 is going to make it steeper, so if I have my original line, my new line is going to be steeper. Which one looks like that? It's going to be, hold on, did I do this right? This, sorry about this. This one's flatter, messed up here, and this one right here, these two are the same. Well, no, this is your f of x. This one's going to go here. It's steeper in it. Okay, sorry about this. So this is the new line. Notice it's getting steeper. You're rotating it up. On this one, you're rotating it down, okay? So this one's less steep. This one's more steep, okay? So just remember, this is going to make it steeper. This is going to make it flatter if it's less than 1. You are going to do wonderful on your test. The linear transformation question, there's only one. Just remember that slope. If it gets steeper, it's going to get more steep. If it's less than 1, it's going to get flatter. 0 is perfectly flat. Keep believing in yourself. You are amazing, okay? You are amazing. You are created to do wonderful things, and you are awesome.